for converting between units. And yes, we do not expect you guys to memorize the conversion factors here. You should have a cheat sheet, some kind of reference sheet to look at when converting between the units. But again, some of these conversions will require more than one conversion. And it's important to see the difference between the two. Usually there's two ways to go. One of them could end up being more easy, but it's difficult to say from the beginning, especially when we're not as when we don't have the experience we want with these types of problems. So once again, we're still going to be using conversion factors. You can see these ones here on the right. These are the ones we're going to be using for length, weight, and capacity. And we're just manipulating these. Okay, so instead of, for example, like weight, instead of showing it as tons, if I wanted to show it as metric tons, I need to use this conversion factor down here to change how the value looks without actually changing the value. And again, that has a lot to do with labels. So convert 9 meters to feet, and we'll round our answer to 2 decimal places if we need to. There should be a lot of rounding on these ones because the conversion factors are not actually rational. You can see decimal places there. There would technically be a lot more decimal places to these, most of them. So on this one, 9 meters to feet. Okay, so again, I start with 9 meters. I'll make it over 1. And that's a length, right? And I see a direct conversion factor right here. 1 foot is 0.305 meters. Now, is it possible to know how many feet are in 1 meter? There is. It is possible. But we don't have that conversion factor in this list, so I'm just going to use this one that we do have. And I know I need to cancel out the meters, changing this into feet. So I have meters in the denominator, feet in the numerator, and this conversion factor shows 1 foot is 0.305 meters. So my meters do cancel. And by fraction multiplication, I get 9 over 0.305. Now in feet, which is what we do want. Well, I'll just simplify this. 9 divided by 0.305, just in the calculator there, which shows as 29.508, we'll see. So the 0 in the hundredths position, 2 decimal places. The 8 in the thousandths is going to add 1 to the zeros, which makes this 29.51 feet approximately. All right, convert 22 ounces to centigrams. And again, we'll do the rounding if we need to. So ounces and centigrams, I assume that's weight. Yeah, it looks like it is. Grams is weight. So on this conversion chart, though, I do not see a conversion factor for ounces to centigrams. What I do see is this conversion factor from ounces to grams. So what I will do on this one to start with is change this 22 ounces into grams first. After that, I will figure out how many centigrams that is. Okay, and we can use that chart like we had before, but we may or may not need to. Let's see. All right, so I start with my 22 ounces over 1, changing this first into grams, using this conversion factor here. So I need to cancel out the ounces compared with grams. So ounces in the denominator, it's 28.35 grams for 1 ounce. So again, we see the ounces cancel. And in my calculator, I got 22 times 28.35. So yeah, we get 623.7. And again, that's in grams. So I'm going to take that 623.7 in grams. And if we think about the chart, I can see that I'm going from our base unit, which is in grams. Grams to this one is centigrams, which is right here. So I'm going from base unit to centigrams. That's 2 box place values to the right. So I need to move this decimal also 2 times to the right, which is going to fill a 0 in that empty place value, which makes this 62,370 centigrams. What about kilograms to pounds? Well, again, let's look at our conversion factors. Kilograms to pounds. Yeah, we got this one right here. This conversion factor, kilograms, grams, and pounds. Again, we're looking in the weight, and this one has a direct conversion, kilograms to pounds. So we start with 104 kilograms. And I'll make it over 1 because we are dealing with fraction multiplication in dimensional analysis. Multiplied by, well, I need kilograms in the denominator, so it cancels. And then I'll put pounds in the numerator. And yes, I'm not using LBS because it just kind of looks weird. Okay? I'm not going to write the whole word pounds out because not only time, but I'm a lazy math guy. So this one shows 2.2 pounds for 1 kilogram. And yes, this cancels out kilograms, which leaves us with pounds. And I can see 1 times 1 in the denominator, so in the numerator, 104 times 2.2. And since I've only got one conversion on this one, I don't need to worry about that denominator being 1. 228.8 pounds would be 104 kilograms. All right, convert 7 liters to gallons. So this should be a capacity question. So I look at my capacity here, and yes, again, this is very nice because we do have a straight conversion factor for gallons and liters. So this one starts with 7 liters. I'll write it over 1. We're going to use our conversion factor with liters in the denominator, gallons in the numerator. This conversion factor shows 1 gallon is 3.785 liters. So the liters do cancel out like we would with a fraction multiplication. But now I got 7 over 3.785. This is in gallons. So I need to put that in my calculator. We'll keep this in gallons, but I'm going to take 7 and divide it by 785. There we go. Now this does show a long decimal, 1.849-ish. And that's all the decimal I need on this one because we're only rounding this 2 decimal places to 4. The 9 is 5 or more, which means I'm going to add 1 to the 4 in the hundredths place value, making this 1.85 gallons. All right, conversions with mixed units. We saw this with the time, right? What was it, like 7 minutes and 33 seconds converted to seconds? So start with convert the starting units into larger requested units. So this would be like something small to big though, right? Like instead of 7 minutes, 33 seconds, you start with a bunch of seconds converted into minutes. But mixed units. So we could be dealing with, for like metric or US units, feet and inches, or wow, that's mostly the time it is mixed units. Let's find out. There we go, time conversion, 23 days to weeks and days. Write your results to 2 decimal places. So the weeks, since it's weeks and days, it's really just a mixed number, you guys. And we know that there are 7 days in a week, okay? So what we can do is, just like we saw in that last slide, so I need to convert this 23 days into weeks first. Okay, now I could come up with a decimal on this one. It's going to be okay if we do. For the dimensional analysis, I got 23 days over 1. Now I know there's 7 days in a week. And I got days in the denominator to cancel out. 1 week, 7 days, right? I'm going to speed this up a little bit because, for the sake of time. So I got 23. I'm just going to divide it by 7, which is a pattern some of you guys have noticed, okay? Now this gives me a pretty ugly decimal right there. 3.2857 and some change. All right. Now, the reason why I did this is because the whole number, even if there was a number in the tens place value or hundreds and so forth, that tells me how many weeks I have. So right there I can see that it's going to be 3 weeks. But how many days? Well, if I did long division on this, that may even be better, right? Because then I'd have 23 divided by 7. Well, 7 goes into 23 3 times. Well, 3 times 7 is 21, which means that the 3 weeks would have taken up 21 days. And now I got a remainder of 2, right? Well, that was already in days, so we can see that the long division actually ends up being very useful. With 2 days remaining, that means that you'd have the 3 weeks with 2 days remaining, which also means that 23 days is 3 weeks and 2 days. So you can see we figured out how many of the larger units there are, and then whatever remained in the long division is however many of the smaller units we had, which was days. So this one will work the same way, right? I want to figure out how many hours 945 minutes will be. So the dimensional analysis would show 945 minutes over 1 multiplied by, again, we got minutes in the denominator, hours in the numerator. 1 hour is 60 minutes. Now I would only show this in order to get to the long division, which is 945 divided by 60. Now, if we're not familiar with our 60 multiplication tables, which I'm not, I would just type this into the calculator, 945 divided by 60. Okay, so it's 15.75, which means that I get 15 right here. Okay, so I go back to the calculator, 15 times 60 would be 900 days, which I subtract from the 945. I'm sorry, I said days. I guess that'd be minutes. And that leaves us with 45 minutes, right? So that 15 was how many hours it is. Because it's 60 minutes per hour, just like we showed here with the dimensional analysis. That tells us how many hours, but we don't want the decimal number of hours. We want to know how many minutes that decimal is. In fact, we'll show that. What the heck? This would have been 15.75 hours, which is good for the 15 hours. But then we needed to figure out how many minutes 0.75 hours is, which could have taken another dimensional analysis. But again, I think the long division shows it much better. 15 hours, 45 minutes. So it's going to work the same way with weight, like we have on this one. Convert 98 ounces to pounds and ounces. Well, we'll start with the 98 ounces. And again, I almost use the dimensional analysis here in order to see what the long division will look like. So I want to figure out how many pounds that, total pounds, or whole pounds that is. And to do that, I'll need to change ounces to pounds. Again, ounces in the denominator, so it cancels. It's 16 ounces for 1 pound. So the ounces do cancel away. So I have 98 divided by 16 in this case. 98 divided by 16. Well, let's see. Again, I'm not familiar with my 16 multiplication table, so we'll do 98 divided by 16. So 6.125. 6.125. Now again, I'm only doing this because it tells me how many times 16 goes into 98 exactly. So that's 6 right there, right? So now I do 6 times 16, which is 96. So when I subtract, I get a remainder of 2. So the 6 there, that's how many pounds it is. The remainder 2, that's how many ounces. So we get 6 pounds. I'll write that out. And these 2 ounces down here. 98 ounces is the same as 6 pounds, 2 ounces.